Hi and welcome back. In this video we're looking at argument unpacking. We've looked at tuple destructuring, and this is sort of fairly related. It's not the same thing by any means, but it's sort of a shorthand to do things. Given the code that we've got here on the left, which should look familiar, is the one we wrote a couple of videos ago, we've got our accounts, and we've got a function to add balance to an account. Let's call the add balance function many times. Imagine we've got a list of transactions like this list I've just pasted here. So it's a list of tuples. This one says the amount of change that happened, and this one to which account it happened. So let's go over these transactions. I'm just going to press enter a few times here to give you a bit more space. And let's say we wanted to add all of these transactions to our accounts. What could we do? For t in transactions, add balance, t0, oh, sorry, forgot the bracket, t0, t1, and that's it. So as you can see, what this will do is, of course, for every transaction, which is a tuple, it'll call t0 and t1, the amount and the name, and pass it to add balance, which it takes in the amount and the name of the account and is going to update it. Now, we're doing something very, very specific here, which is a really popular thing to do, in fact. And that is that we're getting an iterable, like this tuple here, and each element of the tuple, in this case 2 elements, we're passing them as arguments to a function. Notice how we're passing the first argument, the argument with index 0, to our function t0 as the first argument. So the first argument of the function is also the first element of the tuple. The second argument of the function is also the second element of the tuple, and so forth. So this is a very popular thing to do. Each element of the tuple going to an argument of a function. So Python gives us a shorthand. Instead of this, we can do *t. And what that does is that unpacks the iterable into arguments. So *t will pass each element of t as a separate argument to the function. So t0, the amount, will go to the amount. t1, checking, will go to the name. If we had more elements here, they would go to the subsequent parameters as well. Of course, we only have two elements, 2 parameters. So this is called argument unpacking, and this asterisk here is the unpacking operator that we can use to unpack any iterable into arguments. Okay? Pretty straightforward. Now I also wanted to tell you about named arguments. Did you know that in any function call in Python, you can specify the name of the parameter that you're fulfilling with a given value? So you can say something like amount equals t0, name equals t1. This is totally valid Python. So you define the name of the argument, the name of the parameter and the argument value, and you put them an equal sign in the middle. That just makes the function call a bit more readable, so that when you're looking at the function, you know, okay, t0 is the amount, t1 is the name. It becomes a bit less useful if you have a statement above it that says something like amount equal t0, or let's use proper amount name equal t. This becomes a bit less useful, and then you have amount equal amount, name equal name. So this is not so useful, so you wouldn't do this in that case. But when you have a variable that maybe doesn't describe what things are so well, like this t thing here, this can be pretty useful. Because now you know that, okay, t0, whatever that is going to the amount property. t1, whatever that is going to the name property. So t1 must be a string, t0 must be a float, you assume. A benefit of these named arguments is that you can put them in any order you want. So you can put this one here, and this one in front, this one behind, it doesn't matter. It's up to you. So that's named arguments in a nutshell. That's really all they are. You can put the name of the parameter you're fulfilling in front of the value, and then you can jumble them if you want. Okay. So in section 9, a while ago, I'm just going to add some more enters here. In section 9, we looked at this piece of code here that I'm about to paste in. We looked at this piece of code. I don't know if you remember it. We defined a class user with an init method. Username and password were 2 arguments to the init. And then we set the properties username and password of the object. and then it had a class method from dict that took in a dictionary and created a new object of type user from two keys, username and password, in that dictionary. An interesting thing here that I notice pretty quickly when looking at this data is that we've got username and password keys in our dictionary, and we have username and password argument names. So they match. The data that we have, which has a username and password key, matches the argument names, username and password. So this is going to be interesting in a moment. Then we had a list of users. We can imagine that they're coming from a database or something. We've got username is Rolf, password is 123, username Teclado is awesome, password is UR2, and these are two dictionaries here. And then at the end, we mapped over the user.fromDict method for the users list. So that calls the fromDict method for each user, for each dictionary here, passing the dictionary to the method, and then we were able to create a new user from each dictionary. And we also, of course, had the option of saying user objects is user.fromDict, U for U in users. We had the option of doing this list comprehension as well, although at the time I suggested that the list comprehension maybe was a bit worse, because we've got to create this empty variable, the function is already defined, so it's pretty handy to use that here. We don't have to create a lambda function, it's all good. However, now that we have argument unpacking, and I'm about to introduce a new type of unpacking, now that we have argument unpacking, in fact, we don't need this method at all anymore. And in fact, we don't need this either, because what we're going to do now is we're going to do this. We're going to do data username, data password. Okay, so I'm going to build this up. This is nothing new for you guys. We are iterating over users. We're calling each dictionary data. So this dictionary is data, and then this dictionary becomes data. And every time we do that, we're creating a new user object, passing to it data username and data password. So Rolf goes to username, 123 goes to password. We have a new user where the properties are username and password. So we know that. We can make this a bit worse and make it username equal data username, password equal data password. Again, same thing, only now we're using named arguments. We're giving a name to the argument that we're passing in, and that has to match the parameter here. So we're saying username is the data's username property, or key. Password is the data's password key. Whenever you see this, username is something username, password is something password, a dictionary, you know that, you've got duplication here. There's too many usernames in here. There must be a better way. And there is. Instead of doing this, you can do that. I'll do this again. Instead of doing this, you can do this. Notice the double asterisk now. And what this does is this is a dictionary unpacking. It unpacks a dictionary as named arguments to a function. So it does exactly this. It says, get the key of each dictionary, in this case it's username and password, and treat them as named arguments to the function. So say, username is data username, and then, this is another key in dictionary, password. Let's treat that as another named argument equals data password. So this double asterisk data does exactly the same thing as this. Why is that important? It's important because the dictionary may not be in order. And remember, these two can be jumbled up, and that's fine. So you can put the password in front if you want, and it'll still go to the right place because Python can now match them to the name. So that's important because when you do the double asterisk data, the dictionary may not be in order, and that's important here as well. However, let me say that as of Python 3.7, dictionaries do keep their order, and when you pass this mapping into a function, it'll keep the order of the dictionary as well. So and it's not really a problem anymore, but nonetheless, you can still do this, and this is a good thing to do. If you were getting these things from a database, for example, you can see how being able to pass the entire piece of data to a function may be useful. Okay. That's how you do named argument unpacking or dictionary unpacking. Of course, if your users were in a slightly different format, if your users were in the format, I'm just going to copy from my notes just to save you the pain. If your users were in this format, a tuple format, where username is the first element and password is the second element, you know what you can do instead, right? You can just do this. So for each tuple here, you are going to pass them as normal arguments. The normal arguments are called positional arguments. And so same thing here. You can pass them as positional arguments to the user function. So in this case, Rolf would be the first parameter. 1, 2, 3 would be the second parameter. And now you don't know whether it's a username and password. You just know this number 1 and number 2. And this is something you can do as well. Of course, only if the properties are in this type of iterable and not in this type of mapping. Okay, that's it for this video. I wanted to show you about this unpacking and also about named arguments because it's a useful thing to know. Sometimes it can make your functions a bit easier to understand. So that's it for this video. I'll see you on the next one.